All right, welcome back everybody. We got 5.3 to multiply and divide rational expressions. Your first and second learning goal are to multiply and divide rational expressions and then to state the domain restrictions. Now, this is a small review before we do that, and the reason why I want to do this review is because we don't often do in this class a lot of factoring where we have polynomial power 3 or something higher, okay? And I kind of want to just brush on it real quick because we're so used to doing it with x squared as our highest degree, all right? When you're factoring polynomials, more often than not, your first step really can only be, finding the greatest common factor somewhere, okay? I know we have a trinomial on the right here, but you can't do a diamond method factoring with that, okay? You can really only do that when you have a power of 2. So first thing first, always try and take out a greatest common factor. So I look at these two, okay, x squared is in both of them. And so when I divide that out, I get x squared times x minus 1. Pretty simple, right? Now the important part about this is that sometimes after you do this step of taking out a greatest common factor, you might end up with an expression that could be factored again a different method. In this case, x minus 1 can't be factored any further, but what if I ended up with an x squared minus 1 there, right? And that would be a situation where then I could keep factoring it a different way, okay? Now, same thing with the problem on the right. We go to each term, we see that 2 can be pulled out of all three of those numbers, right? And it's the highest one. And then we look at our lowest variable, which is x, and so that can be pulled out of all of them. I know I'm kind of going through factoring by greatest common factor because I've covered those a lot. I kind of want to get to, the after that part, right? So we divide those out. We get 2x squared plus, no, not 1. Well, 1x plus 4, okay? Now, we took out the 2x. We're left with this expression, right? And if you look at this, this is a, kind of looks like a quadratic, right? We got an x squared, an x, a c, a, b, c. Maybe we could do the diamond method after this, okay? And so that's kind of what you need to take away from this is that, maybe a lot of the times you're going to do a greatest common factor, but then you're going to unlock potentially another factoring step, okay? All right, let's dive in here and let's solve one. First things first, I know normally don't write steps, but I feel it's important to write steps on this particular lesson. The first thing you want to do is factor everything, okay? Don't multiply yet. Factor everything first, okay? Once you factor everything, cancel, okay? And I'm just writing cancel, but that means like cancel out any terms that you can cancel out. Make your expression smaller. You'll have to deal with less multiplication, and it'll be easier, okay? And then write it in its most simple form, okay? So that's the first thing that we're going to do here, okay? Now, if I look at this one, there's not too much to factor out, right? This 8x, where's my pointer? This 8x to the power of 3 can't be factored, right? This 2x plus 8, well, this could be factored, right? We could take a greatest common factor out of this. The x plus 4 cannot, and the x cannot. So this is a particular problem where there's only one factoring. Now, we're going to get to some that are going to have a lot, okay? So, brace yourselves. But let's do that first factoring. So we see that 2x plus 8, we can pull out a greatest common factor of 2. So we're going to end up with 8x to the power of 3 over x plus 4 times 2 times x plus 4 over x, okay? So check, we factored everything. Now we can cancel, all right? And we see that we have down here on the left an x plus 4. And we see we have up here on the right an x plus 4. When you see this, you can cancel those out. Gone, gone. Now I know they're across this multiplication, but once I do multiply everything in, this x plus 4 and that other x plus 4 will be right over each other and they'll cancel and be 1. So I can just do it now. All right. Now there is another cancellation we can make here. There's an x on the bottom here, right? There's an x to the power of 3 over here. So when we do multiply this and it's over here, there'll be an x to the power of 3 over x, which is our quotient of powers. So we'll subtract the top exponent by the bottom, and we'll just get x squared. So why don't I just do it now? Cancel it, and then put a 2, okay? Now look at the small amount of things that I have to multiply. All I'm left with is an 8x and a 2 to multiply, okay? So let's do that. 8x squared times 2 gives you 16x squared. Now that's the final answer, okay? Now imagine if, go back here for a second. Imagine if your first step was taking this and multiplying it with that. You would end up with what? 16x to the power of 4 plus 64x to the power of 3 to start off your problem. Probably don't want to start off that way, okay? Now the last thing we're going to do here when we multiply is we're going to state our domain restrictions. So state, let's put it the whole way, domain restrictions, okay? Now anytime you cancel something out, okay, you're going to have to, keep track of that, okay? Because that still factors into your domain restrictions, okay? So here we canceled out that x plus 4. So the only thing that could have made this x plus 4 a 0 on the bottom here, because remember, that's the whole point of our domain restrictions. We don't want 0 on the bottom, would have been a negative 4. So we're going to write that. So, our domain restrictions, we have x cannot equal negative 4. And then we also had an x on the bottom on the other side, so x could not have been 0. And these would be our two domain restrictions, okay? And this would be our simplified answer after multiplying. Okay, so that was a lot. I know I wrote you do on this one, but that's a lot more. Let me go ahead and do this one, okay? I'm going to have to make some changes for the next time I do this, all right? Because this is a huge jump. All right, let's start it off, and then I'll probably have you guys switch it up. Maybe I'll have you guys do the next one, okay? So factor everything, okay? So I'm going to look up top, 5x can't be factored, but I can factor this, 3x minus 3. That has a GCF of 3. Now here on the bottom, I have an x squared plus x minus 2. I'm going to have to use diamond method for that. And then over here, I have an x to the power of 3 plus 3x squared. We have a greatest common factor again. So greatest common factor, and that's going to be x squared, okay? So 3 out of 4 of these, 3 out of 4 of these terms can be factored, okay? But the first one, 5x, can't, so I'm going to leave it. And then the top one, if we divide out that 3, we get 3 times x minus 1, okay? And now we're going to have to do the diamond method here, right? So we have a times c on top, so that's 1 times negative 2 to be negative 2, with a 1 on the bottom. We ask ourselves what times what gives us negative 2. That adds to be 1, and the answer is that would be 2 minus 1. Now I can write that into their factors. So x plus 2 times x minus 1. And then finally, I'm going to divide out that x to the power of 2 out of this. And so I should get x squared times x, plus 3. Like that. Yeah, that looks good. Okay. All right, so we've done all the factoring, right? Everything is completely factored. Be careful, sometimes you might see some difference of squares, but there are none here, okay? Because we didn't have any, well, we did have a power of 3, but we didn't end up with a difference of square after taking it out. So we can move into our next step, which is to cancel, okay? Cancel out the things that we can, okay? All right, so I'm looking and I see I have an x minus 1 and an x minus 1. So those can be taken out, okay? Now I do have an x on the top left and I have an x squared on the bottom. So that, how do I say this? This one's a little harder to see, But if you think about it, only one of these x's on the bottom can be taken away from this one, right? Because we have a 1 minus a 2 if we did quotient of powers, right? X to the power of 1 over x to the power of 2, which would give us x to the power of negative 1, which would mean we just need to send it right back to the bottom. Another way I would think about that is you have two x's here. Just cancel out one of them, okay, and leave the other, all right? So let me rewrite this so we can kind of see what we have now. We have 5 over an x plus 2, all right, times a 3 over an x times x plus 3, okay? All right, now we still got a lot going on here, all right? Okay, so let's multiply these together, and we're going to get 15 over, and we got a lot here, so x times x plus 2 times x plus 3, okay? And we're going to leave it like this, okay? Now, I know you're probably thinking to yourself, well, I could multiply all of those things back together, right? And that should be the most simple form. But we want to leave these factors separately so we can instantly see, boom, domain restriction, boom, domain restriction, boom, domain restriction, okay? So let's write out those domain restrictions. That's our last thing. So off the bat, let's go to the ones we canceled first. We canceled out a -1, so that means that x cannot equal +1, okay? All right. Now we did cancel out an x, but there is still an x in our answer, and so that really, they're both telling us the same thing here, okay? So the first x tells us that x can't be 0. The second x can't be -2. And then the last x cannot be -3, okay? So that one has 4 domain restrictions, and that's totally fine, okay? So this one was a little bit longer. Shouldn't have made that a you-do. My bad, okay? All right, let's jump into, we're moving on to dividing. Okay, so you're not ending up probably looking like there's not going to be too many you-dos on this one. That's my bad, everyone, all right? Now, dividing rational expressions. Okay, I know you're like, whoa. I'm just getting the hang of multiplying. You're moving on to dividing. What's going on here, Mr. Farrow? Okay? But multiplying and dividing are very, very, very similar, okay? The only difference is when you divide with fractions, you have to flip and multiply, which means then it turns right back into a multiplication problem. So the first thing you should do is keep, change, flip, okay? So we should rewrite this. We're going to get x squared plus x minus 6 over x squared plus x times x over x plus 3, okay? Because we keep, change, flip. And now look at this. It's not even a division problem anymore, right? It's just back to a multiplication. And so you know what? I think you guys can do this one. So why don't you guys pause it, give it a try, and then I'll go over it. Okay, so hopefully you gave this a try, and now you're treating it like it's a multiplication problem. You're going to factor everything. Okay, and we're going to start here with that top left. We have that x squared plus x minus 6. We need to do the diamond factor. We get a -6 up top, a 1 on the bottom. We ask ourselves what times what is -6 that adds to be 1. The answer to that would be, what, 3 and -2. So this top becomes x plus 3 times x minus 2. And this would be over x squared plus x, but we're going to factor that in a second. The top right does not change because it's just an x. And the bottom right does not change because it's just a plus 3, but you're probably already seeing that that's going to be canceled out, right? Now the x squared plus x, we have a greatest common factor of x. We divide that out, and we get x times x plus 1, okay? Now, we factored everything. We need to cancel everything out that you can, okay? Now this problem, it's only looking like we can oh no, we can't. We got an x and an x, right? We have an x plus 3 and an x plus 3. So this whole term on the right even canceled out. And our final answer is just x minus 2 over x plus 1, okay? Now we got to do our domain restrictions. We cancel out an x, so x cannot be 0. We canceled out an x plus 3, so x cannot be negative 3. No, that's all we canceled. And then on the bottom, though, we still have an x cannot be negative 1. So remember, those numbers are, if I plug them into the expression that they came from, they would be equal to 0, and we can't have a 0 in the bottom place. Now, just a quick reminder here, these, and we covered this in the last lesson, these were your discontinuities. I'm just going to stop there. And then this would be your asymptote, okay? So just, quick refresher on why one of them stays in, other ones leave, all right? Okay, we only got one more problem and then a math talk here, okay? So, this is a you do again. It's a little bit longer of one. I know it's harder, but you should try this before I do it, kind of see if you're getting the hang of it, okay? So why don't you guys pause it and give it a try. Okay, so hopefully you gave that a try, all right? Remember, division, so we need to keep change flip, so we end up with x minus 6 divided by x squared plus 2x minus 24 times x squared minus 4x on the top now over x squared minus 36, okay? Now, we did our keep change flip, so we are going to go into factoring everything. The top left is good, the x minus 6 can't be changed. The x squared, so let me write that again, okay? The x squared minus 4x, we can factor out our x there, so we end up with x times x minus 4, okay? And then the bottom left, we're going to have to do a diamond factor. We get a negative 24 on the top, a 2 on the bottom. And so 6 times 4 is 24, but 6 times negative 4 gives you the negative 24, and 6 minus 4 gives you 2, so that's perfect. So we end up with an x plus 6 times an x minus 4. And now the bottom right is a little bit harder to catch here, but this brings you back to your difference of squares. You have a square, you have a square, you have the difference, and so you write those, right? So you have, remember, let me actually give you a quick refresher, okay? You take the square root of each of them, so the square root of the first one, you put in the place of the first of each term. So the square root of x squared is x, so we put an x and an x. The square root of 36 is 6, so we put a 6 and a 6, but one is plus and one is minus, okay? Now we're going to start looking for anything that we can cancel out. I see an x minus 4 and an x minus 4 across. And I see an x minus 6 and an x minus 6 across. Now we have two x plus 6's on the bottom, but now that means we just have two x plus 6's on the bottom. That's fine, okay? Now we go to write this as something more simple. We only were left with an x on the top, and then we have two x plus 6 on the bottom. You can leave them separate or bring them in as one binomial and call it a binomial squared. It's really no different, okay? All right, now we need to do our domain restriction. So domain restrictions, x cannot equal, and let's see, we took out x minus 6, so x cannot be positive 6. We took out an x minus 4, so x cannot be 4, right? And we're left with an x plus 6 on the bottom, so x cannot equal negative 6, okay? All right, so that, these problems are starting to get long, okay? And you're doing a lot of factoring, right? We're doing factoring on greatest common factor, factoring with difference of squares, diamond method, right? It's a lot of stuff, okay? Now your last thing here is a little bit of math talk, but I just wanted to, little simple one. Expressions lead into equations, okay? You might ask yourself, what was the point of all of this? Well, we're isolating the skill of working with rational expressions so that you can use these skills of simplifying them later. If you know how to simplify a rational expression and you have to multiply two different ones in order to get to a new type, right? And then solve an equation with it or graph it, you're going to know how to do that. Okay, so this skill is really about working with other skills, okay? So hopefully you guys enjoyed this video, and I will see you guys next time.